In Module 8, we're going to start talking about medians, midsegments, angle bisectors. We're also going to talk about perpendicular bisectors and altitudes. So the first three are in this video, and a median of a triangle is a special segment whose endpoints are the vertex of a triangle, and it connects it to the midpoint on the opposite side of your triangle. So if you look at our picture over here on the right, you can see that this is the median. So it connects the vertex up here at point B to the midpoint on the opposite side of our triangle. Remember that the midpoint creates two segments that are congruent to each other. So every triangle has three medians, and the intersection of the three medians is called the centroid. And the centroid is the balance point, or it's called the center of gravity of the triangle. So in the triangle over on the right, you can see right here that this point right here is called the centroid because we've got three medians and they all intersect right there at the centroid. So the centroid theorem tells us that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint on the opposite side. So what you want to think of is there's a longer piece and there's a shorter piece. The longer piece is going to be 2 times as long as the shorter piece. So if you see my segment right here, so CZ, I like to think of it as it's 3 equal pieces. You have one already, and if you divide this one in half, then you've got 2 more that are equal, so you've got 3 altogether. And that's what we're going to do for example 1, is we need to find the distance from A to G, but we do know that CE is 7.2 and AF, so the whole distance is 9. So the easiest thing to do is to draw the segment. So this is from A to F, and we have a longer piece from A to G, and we have a shorter piece from A to F. So what you want to do is the longer piece, cut that in half, and then we've got 3 equal pieces. So if AF altogether is 9, then that means that each of these are 3. And then depending on which piece they're asking about, you can just add the pieces together. So AG takes 2 of them, so AG is equal to 6. Then if we do the same thing for our EC segment, so remember we have to divide the longer piece in half, and then we've got 3 equal pieces, and it says that CE, so the whole distance, is 7.2. So we need to take 7.2 divided by 3, and that gives us 2.4, so each of these are 2.4. So you can label all 3 of them, so 2.4, 2.4, 2.4, and if we want G to E, that's just one of the little pieces, so it's just 2.4. On example 2, if AD is 21 feet and BC is 18 feet, we want to find the perimeter of triangle ABC. So if you notice, AD is the median, and so if it's the median, it connects the vertex to the midpoint, so our point D is our midpoint. So if you notice, both of these are 9 because it cuts the 18 in half. But now we've got a right triangle, so we have to use Pythagorean theorem to find out what segment AB is going to be. And if you notice, both of the triangles are congruent to each other, so they're both going to be the same size for the AB and the CAC, so we make little congruent marks on those. So you have to take our 21 squared plus 9 squared equals x squared. And once we solve that, we end up getting x is 22.8. So if I label that, so 22.8 are each of these. So my perimeter of my triangle is going to be 63.7 feet. Remember at the very beginning I said that we're going to learn about 3 special segments in this video, and that's medians, midsegments, and angle bisectors. So we've already talked about medians, but we're going to talk about midsegments now. So a midsegment of a triangle is a segment that connects the midpoints of 2 sides of the triangle. So every triangle has 3 midsegments, and the midsegments of this triangle ABC are DE, so segment DE, segment EF, and segment DF. The midsegments theorem is going to tell us some more things about the midsegments and how it compares to one of the sides in the triangle. So the segment connecting the midpoints of two sides of a triangle is parallel. So the midsegment itself is parallel to the third side. So think of our DE up here is parallel to AC. We could say that EF is parallel to AB, and BC would be parallel to DF. So think of parallel lines and different angles that will be congruent as well because of that. So the midsegment will be parallel to the third side, and it is half of the length as long as the third side. So lengthwise, it's going to be half the distance. So when we're looking at our triangle RST down here, so RST, we need to put some different measurements in here. So if V is the midpoint, that means that these are congruent to each other. So that means that each of those would be half of 10.2, so only 5.1. Next, that would mean if this is 5.6, then I need to double it. So 5.6 times 2, and that gives me 10.4. And if W is the midpoint again, that means that both of these are also 5.6. Oops, sorry about that. So that's not 10.4. That should be, let's see, 11.2. I wrote the wrong number down. So this is also 5.6. So if you notice, the midsegment and then both halves of the side it's parallel to are going to be congruent. So you almost have three equal pieces there. So some of the pieces we already have is we have that each of these are 5.1. So the side that's parallel to it, this is half the distance of this 10.2. So that is also 5.1. So UW is 5.1. Next, we need to find what RT is, and we already mentioned that. That's this 11.2, so we had to multiply it, the 5.6 by 2 to get 11.2. RW, we've got that already. That is 5.6 because our point W is the midpoint of side RT. And angle UVS, we don't have any angles yet, but UVS, if we look where that is right here. So it's this little missing angle. So remember, we have some parallel lines in here. So we have UV is parallel to RT. And since we have this one angle that is 41 degrees, and we have this other side that's also parallel to it, that means that these are alternate interior angles. So that is going to be 41 degrees as well. And our reasoning for that answer for letter D is because we've got two parallel lines that implies that our alternate interior angles are congruent to each other. On the next page over, we've got angle bisector. So an angle bisector divides an angle into two congruent angles, and a point on the angle bisector is equidistant from both sides of the angle. So if we're looking at our picture, that'd be XD is going to be congruent to DY. And in our figure, BD bisects, so ray BD bisects the angle ABC. So that tells us in our picture that we've got congruent angles, and it also tells us that if we connect that point D directly to the edge of the angle, that it will be perpendicular, and it's going to be the same distance away from each of the sides of that angle. So XD is going to be congruent, so the segment XD is congruent to the segment DY or YD. So in our picture down below, we've got YW or WY bisects angle XWZ. So these two angles will be congruent to each other. And when we are filling in the first answer. So XWY is just this angle right here, so that's equal to this one. So we need 3 letters. So YWZ. There we go. All right, so if XY is 9, so if that's 9, then that means that ZY should also be 9, so it's the same distance away from the edge of the angle. If XWY is 25 degrees, and we want XWZ, notice we've got 2 of those. We need to double it, so we would get 50 degrees total for that missing angle. In a triangle, if we've got 3 angle bisectors, so if you see them in this triangle, so I've got 1, 2, 3 angle bisectors, that they all intersect at one point in the middle of the circle, or in the middle of the triangle, and they will be the same distance directly to the edge of the triangle. So they will be equidistant from each of the sides of your triangle. So in our figure, the angle bisectors intersect at point P, and that point P is called the incenter. So in our next picture, we have ST and US are angle bisectors. So in our picture, we want to mark that those angles are congruent to each other. So it's cutting each of those angles in half. So notice this is 15. So we know this other angle must be 15 as well. And it also says that SR is 3 centimeters. So with the parts that we are given, we have that we want to find what the angle of RUS, and RUS gives us 15 already. And if we want to figure out what VTS is, that's just this little piece, we need to look at the big triangle as a whole. So we've got 110 degrees. This angle over here for angle U together would be 30, and we need to figure out what the whole angle T will be. So 110 plus 30 together already is 140. So the remaining angle must be 40 degrees. So this whole angle together is 40, but I only want one of them. So I need to divide it in half, so I get 20 degrees for each of those individual angles at angle T. So what is the perpendicular distance from S to VT? So that means going directly over. But remember this picture up here, they should all be the same distance away to the edge of my triangle. So if this one is 3, then the distance from S to the side VT should also be 3 centimeters. So one of the things that was mentioned earlier is that when we have medians or angle bisectors, or we have altitudes or perpendicular bisectors, we are going to have where they meet in the center, and there's a certain name for that point. So with altitude, this is just a way to remember it, so kind of a little acronym. So look at the letters I have underlined. So I have an A, O, P, B, C, M, C, A, B, I, and those stands for something. So in the first one, altitude, if we have 3 altitudes in a triangle, they will meet together in the center, and that point is called the orthocenter. The next one is perpendicular bisector, so PB, and where 3 perpendicular bisectors meet is called the circumcenter. So it's almost like circumference, but it's circumcenter. Next is the median, so where you have 3 medians that intersect in the center of the triangle, that's called the centroid, so M and C. And lastly, the one that we just learned about was the angle bisector, and where 3 angle bisectors meet in the center is called the incenter. So this is just an easier way maybe, or a way to help you remember what the different names are that go together. You might want to color code yours as well to help you narrow down what goes together. But an odd peanut butter cup may contain apple butter instead. Will just be a way to kind of pair all those up together.